All right, so the goal of this presentation is really to talk about the way that all the stormtroopers and whatnot that you see at conventions make the costumes. It looks really intimidating and unusual at first to think about formed plastic, but it's actually pretty easy. I mean, this system here is a small demo one, but I built this for about $50 in scavenged parts from failed home appliances. So you can actually do this stuff pretty cheap, and it's really kind of fun. So this opening picture is from a one-day project that some of my friends and I did. We had a bunch of people from Philadelphia came up to our house. They stayed for the weekend, and we tried to see how much clone trooper armor could we make in one day if people were dedicated. So 2 of the Pennsylvania natives who came out spent 14 hours without taking any breaks at the vacuum forming equipment and churned out 15 full sets of clone trooper armor. Wow. So they've effectively outfitted their entire 501st Garrison in clone suits at a cost of about $125 per suit. So it was a lot of labor, but it was a good sort of social bonding experience, and everybody got to learn something and have some fun. So that was pretty cool. Just gonna pass on. Ooh, fancy. All right, so basically, in its simplest sense, thermoforming is just a fancy word for heating up plastic and molding it into a shape. Certain plastics are called thermoplastics, and when you heat them and pull them into a shape, as soon as they cool down, they'll hold that shape forever. So you can twist and shape them into almost any configuration. You know, there are limits. If you try to stretch it too far, it'll tear, things like that. But for the most part, you can make some pretty complicated shapes. Disclaimers. If you want to try this at home, awesome. If you set yourself on fire or electrocute yourself, not my fault. You're dealing with high heat and electricity. If you're not aware of how to do that safely, you shouldn't be playing with it. My home system is wired to a 30 amp 220 volt electrical circuit. So while this one, if I were to zap myself on it, I'd say ouch and fall back. That one, if I zap myself on it, I'd probably hope somebody was there to call 911. So, you know, it's great to play with it. I fully encourage experimenting, but just don't do anything that you're not sure you know how to do safely. And also the covering of your butt, in case anyone's nervous, you have a fire extinguisher. Next. So this is not a new hobby. Mattel produced these in the 1960s, and it was almost exactly this contraption, just in a plastic box rather than a wooden one. And it was a kit where you would get sheets of plastic and a heater, and instead of a vacuum, it actually had a little pump that you would pump it down. And you could make toy cars, toy boats, all sorts of neat things. Unfortunately, as we got to a world where everybody was a little bit more concerned with safety, they decided that this was too dangerous for small children to play with, so they discontinued them. Which is sad, because I think this is an awesome toy, and they're really expensive to get now. You pay a couple $100 for one of those on eBay. So really, you're looking at a few core components when you want to do a system like this. And you can do it in almost any size you want. This one is a 5.5 inch square working surface. I have a friend who has one that's 24 by 48, which is about the biggest you can do without getting into mechanical assistance and really high-end commercial equipment. But really, you're looking at heat source. So here we've got, my heater is an old bread machine that I gutted for parts. The little anecdote off to the side, but the bread machine committed suicide. It couldn't stand to make one more loaf of bread, so it vibrated off the counter and splattered bread dough everywhere. But it's now a vacuum forming machine and part of an R2-D2, so it lives on. Then you have the forming surface, which is really, we'll get into it a little bit more later, but it's really just a board with a bunch of holes in it that you hook up to the vacuum. And there's the vacuum. In this case, I'm using a shop vac. At home, I have a big commercial vacuum pump, which is the same deal, just it sucks harder. You have a positive form, which is the shape that you want to duplicate. I made this up for this demo. It's just a little clone trooper face, which conveniently is the perfect size and shape for a demo table. And you have plastic. These little sheets that are sized to whatever you want to do. In this case, I'm using fairly thin plastic, but you can realistically go up to 1/8 inch thick on a home machine, maybe thicker if you're patient and lucky.
Where do you get your plastic?
That's actually an interesting question. Depends on how much I'm buying. The last time I did a big order of plastic, I bought 1,100 pounds of it in one shot. So in that case, I ordered it from a plastics manufacturer in Arizona because buying it in that kind of bulk was cheap enough to offset the $500 for shipping on the order. If I'm getting a smaller amount, there's a place in Billerica, Laminated Plastics, which is really good. Their prices are good, and they're willing to sell you as little as 1 4-foot by 8-foot sheet of plastic, which is kind of rare from suppliers. Most of them want, 200 pounds, 500 pounds, something like that. This, since I was getting a very small amount, I actually got from Amazon. They sell 24-inch square sheets of styrene that I just cut down. They were like, it was $7.50 for a 24-inch square, which was big enough to make 9 pieces for this table. So it was a pretty good deal, but it really depends on the kind of volume. Whenever you can buy more, it's good pricing-wise, so that definitely helps. And then the last piece of it is the plastic carrier frame, which is basically, as the plastic heats up, it gets soft and squishy. So you need something to keep it in the right shape. So this was me learning how to weld. For this kind of system, it's really excessive to have a welded steel frame, but it was a good proof of concept, and it gave me an excuse to play with more electricity. So the heat source, as we talked about, can be really anything. It just needs to get hot. Some people use the electric griddles that you can get at Walmart for 20 bucks. You get a nice 10-inch by 16-inch or so heating element out of that. You can use a bread machine, toaster oven. If you have the space and are getting into this more seriously, an electric household oven is awesome. I don't recommend using the one that you actually cook your food in, because one wrong move and you've ruined your household oven. Basically, the plastic will not produce any terrible odors or make any huge mess unless you cook it too much, at which point it will liquefy on your oven. So if you're going to use a household oven, use a second household oven.
What kind of temperatures are we talking about?
Ideally, it depends on the thickness of the plastic, but it's around like 175 to 250, depending on what you're cooking. Different plastics have different properties. Like I'm using styrene here because it's very easy to work with. And this, about 175 is the ideal temperature. When I do the demo later, you'll see that basically the plastic will get very soft and elastic. So if you push your fingers, it'll spring back to its shape, but it's flexy. If you get any hotter than that, you end up burning the outside of the plastic before the inside gets sufficiently soft. And again, for this, where this plastic is so thin, you don't really have to worry about it. But if you were dealing with 1/8-inch thick plastic, it's a concern about what the bottom temperature is versus the top temperature. You want it to be kind of consistent. So for something like that, you want to go a lower temperature and a slower cook time. If you try to blast it with a lot of heat, you'll burn one side and the other side is still firm. So there's a lot of experimentation and kind of learning the material you're working with and figuring it out.
Hey, you just flip to heaters, one on top of the other, and have the space in between?
You can, but then that gets into complicated logistics of how do you get the plastic out of the way of that and get it onto your forming surface successfully. So, yeah, it's doable, but it's definitely tricky.
What about a steam press? Like they use for like dry cleaning or whatever, that they're full heated for clothing. Does that get hot enough? Because I know they usually have a stick resistant surface.
It might. I've never seen anyone try anything like that, but there's good potential for that. It's really, as long as you can get a consistent, even temperature and not have big hot spots in one area or another, there's a good chance it would work.
So you're basically talking about just putting the plastic in the frame, in the oven, heating it, and then molding it?
Yep.
What about just a convection oven? That moves the air around and heats more surfaces.
Yeah, I mean, it's said, pretty much anything that will get warm. One of the tricky parts, I think we've got some pictures in here of an older system I used to use. When you're working with an oven where you have to pull the sheet out and then take it to your forming surface, you do run into problems where you start to cool down immediately as soon as you take it out. So you have to be very fast and very precise. If you're in an oven and you have to pull it out over here, bring it over there, and pull it down. So as you can see, that's it's a view from below of my oven. So the system that I have at home, which is a more full picture later, the heater is up here, the plastic slides up and down, and the forming surface is below. So you raise it to the heat. When it starts to sag, you pull it straight down on track so that it can't shift. With everything in this kind of hobby, there's just a lot of experimenting and a lot of trial and error. You know, I only show the parts that I did well. I don't show the horrors that have come before. A couple folks in this room have been there for us doing some marathon sessions in very bad conditions, but you learn from it.
Can't believe it.
I believe the old vacuum forms, they used a light bulb at one side, and you heat it, and then you took that frame and just rolled it over to the form, and then
Yep.
did the vacuum.
And
Yeah, very
that's,
quick.
you know, we refer to that as a flip-flop system, and those work great unless you're trying to pull something very large. If you have a big object and you flip, your plastic hits it here before it has a chance to go down, and it stretches unevenly, so you get thin spots and thick spots in your form.
If you were to turn your bread maker upside down.
That was actually my original thought on this, to try to mimic this design. But my concern was that this is not the greatest heating element for this, because it's got a big gap in the middle, so it's just heat around the edges. So the reason I left the box as tall as I did is it's actually letting the air in here heat up and try to make it a little more consistent. If my heater was on top shooting downward, I'd be fighting against heat's natural tendency to rise, and I wasn't sure if it was going to work right that way or not. So I decided to play it safe in this one, because really I just wanted something that would work for a presentation like this rather than actual production.
So in this system you have here, the heating element on the right, you heat it up, and you lift it up and put it over the form.
Yeah, and this one I basically just, when it's ready, I just go like that. We'll get there. Now move on to the next one. So I mentioned just a second ago drooping. So when the plastic starts cooking, it will sag a little bit in the middle. And this is another of those very unscientific, artsy parts of it, where depending on the shape that you're forming, you want more or less droop. So if you're trying to pull a very tall piece, you want the plastic to sag, because then it stretches evenly and consistently, and when you pull it down, you don't get thin spots where you're stretching it over the plastic. It's already created sort of a little bubble that it can fit into. If you're doing a very small piece, you don't want a lot of droop, because then you can get ripples and bubbles where there's more plastic than it knows what to do with, so it just forms webs across your piece. So you really end up experimenting and just learning, you know, for each positive form you have, you learn a different level of sagging and a different level of cook time to really make it work right. And that's another of those unfortunate trial and errors where when we were prototyping the clone armor that I built, we spent hours working on, try this, nope, that one didn't work, throw it away. Try this, nope, that one didn't work, throw it away. Until we finally said, okay, for this piece, we want to cook it for 5 minutes. And then we do that for the next piece.
Can you reuse these at all?
It depends. If you stretch the piece out a tiny bit, you can sometimes reheat it and get it to go back to a decent shape. If you stretch the plastic too much, it'll never really recover from it. So unfortunately, most of the time, the failures are just complete waste. So you end up trying to find a place that will recycle them. You know, like we're lucky in Waltham, they'll actually take this stuff for curbside recycling. So I have big 55-gallon trash barrels that are just labeled with the recycle logo, and the recycle people take away all my scrap plastic, so I don't have to worry too much about it. But you know, there is definitely a waste issue to deal with if you're doing large volume production.
Here we go.
All right, so we started talking a little bit before about the forming surface, and you know, you'll see people on prop making boards call it the platen, you'll call it the plenum box, you'll call it the forming surface, you'll call it the thing with the holes. Like there's all sorts of different words for it. But basically, what you're doing is you're taking your vacuum and you're distributing it across a large flat surface through a bunch of holes. So what we have here is a little sandwich. There's a 1/2-inch layer of plywood, which has the flange that the vacuum connects to. Then there's an 1/8-inch thick spacer. Then another piece of 1/2-inch plywood that has the holes on it. You want the spacer to be thin because when you start the vacuum, it has to evacuate the air from your box before it starts actually pulling down your plastic. So if you make this box 4 inches tall, it has to pull all of that air out before it can start forming, at which point your plastic is cooled a little bit and you've lost some work time. So the thinner you can make that box, the more efficient you'll be. Some people will even go so far as to put little thin strips in between all the holes to take out as much space in there as possible, but I haven't found that necessary myself. And some people will also make these out of steel. You can do a nice, hammered smooth steel finish, but I've always found that plywood works perfectly well. I seal the edges with silicone just to help make sure that no air leaks through the seams. But otherwise, on my home system, which you see there, I've done probably about 600 pulls of plastic on there since I built it, and I've never had any issues with just plain plywood. So you'll see people say, you know, oh, you have to do aluminum, you have to do steel, but that adds a lot of money and time to it, and I don't find it necessary at all. So vacuum is a fun one, which I got to learn all kinds of sciences that I didn't need to know. So vacuum is very intuitively measured in inches of mercury displaced, which is how much will the vacuum drop a barometer. And it took a long time to come to terms with how that was relevant to my own life. Really what it means is a bigger number is better when you're looking at your vacuum system. You know, a little tiny shop vac like this, I mean, I'm lucky if this is 5 inches of mercury, if that. A big heavy duty shop vac might be 10, and a commercial pump can get as high as 29.9, and I believe 30 is considered, you know, quote, perfect. So, depends on what you're doing. You know, for an application like this, I mean, this thing is fine. It does the job, you know, it makes little clone faces nice and happily. For my home system, I go for about 25 inches. The vacuum pump is typically the most expensive part if you're building a heavy-duty vacuum forming machine. They retail for around $1,000. I got mine on Craigslist for $100. It was a company that was going out of business that did inkjet printer cartridges, and they had vacuum pumps for shrink wrapping the cartridges. And it was one of those sales where you go in and buy, you know, the shelves, the tables, the power strips, anything. And so they had listed these on their posting, and I went to the shop. I was like, oh, how much are these pumps? Like, $100. Like, great, awesome. So if you shop around, you can definitely get them cheap. And if you can get a cheap vacuum pump, that's, you know, the key to a cheap system.
I do woodworking. How about a dust extracting system? I have a horsepower dust extractor.
The problem with those is very similar to shop vacs, where they're designed to move a lot of air very quickly, but not with a lot of power. So the vacuum pump that I have, you actually can't even work with it directly. You have to hook up tanks to it. You evacuate the tanks because it's very slow. It takes it about 2 minutes to pull down the tanks to empty. And then when you open the valve, it rushes out in maybe a half a second. So it's just a very quick rush, where shop vac will pull a lot of air very, very quickly, but not with a lot of enthusiasm. If you notice, you know, if you put your hand over the inlet and you hear the engine sort of ramp up where it can't pull any more air, you get to that point very quickly with them, and they just can't pull any harder, where a commercial pump will pull with a lot more force. And you can see it, like, if you were to compare, like, this table has 1/8-inch holes in it because I'm working with a shop vac and they're not very strong. On a commercial pump, it would actually pull the plastic down into those 1/8-inch holes, and you'd have to fight to get it back out because it pulled so hard it could actually pull the sheet down into that little gap. So with a woodworking dust collector, you could probably get reasonably decent forming on not very complex pieces, but I wouldn't recommend trying to do thick plastic or any big complex shapes.
It says 15 to 18 inches of mercury.
That's actually pretty good. You know, I usually pull at about 22 to 24, so I would say at 18 you'd probably be in good shape unless you were trying to do, you know, 1/8-inch thick plastic over a big shape or something.
Grizzlies are about 300 bucks.
Nice. I bet they probably have them in Harbor Freight too. You going to the next one?
No.
No, that's too bad.
Not that big.
So the positive form. You know, when you're designing a positive form for vacuum forming, the big thing you want to avoid is an undercut, where anything angles down, because your plastic comes down over it and pulls to the shape. If it pulls into an undercut, how do you get your piece back out? You then have to take a razor to it and very creatively cut things, and so ideally you want to try to avoid that. The other thing, which you can probably see on here, is there are little air holes. That's because, you know, for this indent, once the plastic pulls down over it, you need something to be able to let air pass through to pull it down into that shape. So when you're designing your positives, you really just have to think about, you know, what is the air going to do, where is the air going to go, and where is it going to pull my plastic? And sometimes there's a little bit of tuning, like you can also see in the profile, I've got little grooves under here. That's so when it's sitting on the table, it's not completely blocking these holes that are underneath, it's still making use of them because they're pulling air down into those little grooves. And later on, when we get to the end and you can kind of pass stuff around, this was the first little clone face I made on here, and this was the second. The first one I hadn't drilled the holes yet, and when you look at it closely, you'll see the cheeks are barely indented at all. Drilled a couple holes in them, and now they go nice and deep. So when you're designing your positive form, usually do one, you say, oh, that spot didn't come out very good. Drill a hole, try it again. Okay, now that one looks good.
What material do you make positive form?
Actually, got that. The thing with the positive forms is they're going to be subjected to high heat and high force. So it needs to be durable materials. I typically use a lot of Bondo because it's very cheap. You know, you can get a gallon of Bondo for 20 bucks at an auto parts store and just build up a pile of it and then carve it. This is made out of epoxy sculpt, not epoxy, apoxy. It's kind of like the plumber's epoxy you find at Home Depot, but it cures very slowly. It takes 24 hours to harden. So you can actually sculpt with it like a clay, but once it's fully cured, it's machinable, it's perfectly temperature resistant, you could throw it across the room and it won't break, and it can stand multiple repeated applications of heat and pressure.
If you're only trying to do something maybe 3 or 4 times, would you use something less like a plaster of Paris or something like that?
It's actually, plaster of Paris is an interesting one. I've never successfully gotten more than 2 pulls out of a plaster of Paris positive. Whereas if you use UltraCal or HydroCal, which are similar materials and similar in pricing, you can get dozens out of the same thing. So you won't find UltraCal at a hardware store, but you will find it at art supply stores, places that do sculptures. It's used a lot of times for lawn ornaments, the little like lawn gnomes you get. Those will be made out of something like UltraCal or HydroCal. And it's same idea, you mix the powder up with water and let it cure, but it just cures to a much, much harder finish. Yes?
What sort of mold releases do you use to get stuff off?
Generally speaking, you don't need one. Unless you have deep undercuts, the plastic won't stick. You don't really want to use mold releases because they end up getting gooey under the heat. If you do find sticking, some talcum powder works really well to help release it. But if you try to use something like a silicone spray or something like that, you'll find it getting hot and gummy and sticking to the inside of your plastic. And particularly where the work that we're doing is armor that we're wearing on our bodies, we want to make sure we don't have silicone goo sticking to us for the rest of the time we have our armor. The next one. And tap. So here's an example of how I make a positive form. This is the chest for my clone armor, and those are slices of MDF. So I basically drew out what I wanted it to be, and then carved it out into 3/4 inch thick slices, and cut them all to that general shape. And you can see they're all numbered, left 1, left 2, left 3, so I could remember how to put them all together. Tap. Then I slathered it all in Bondo, making it look very pretty. Tap. Started
That's
carving
to
out.
smooth it out?
Yep, to smooth it out, bond the pieces together, kind of protect it, and then that let me start carving out the details in the chest. One more tap. And then sand it smooth, and then there's my positive.
What do you do? How do you carve it?
I have every sort of sanding and rotary tool device any hardware store has ever made.
Which one works?
I mostly use 2 different Dremels. I use a battery-powered stylus style one for small detail work because it's easier to brace it and get precision. And then I use a higher powered Dremel with a flex shaft extension that hangs from my ceiling. It's got a 3-foot long extension on it.
Fordham handle.
Yep, and just pass that around. I also use a lot of small belt sanders, like 1 inch, 1/2 inch, 3/4 inch type handheld belt sanders. And one of my favorites was something that I got from Grizzly, which I call it my rolling pin. It's a big inflatable sanding rolling pin that goes in the chuck of a drill. It's got a handle on one side that spins, and then the drill on the other, and you can pass it back and forth like a rolling pin. And it's awesome. It inflates with a bike pump, so you put the drum sander on it, blow it up with a bike pump, and then you can just sand away like you're making cookies. So that's great for an area like this where you're trying to go around a big curved spot. That's great because you just kind of pass it back and forth, and you end up spraying dust absolutely everywhere, but that's kind of part of the fun. Always wear a breathing mask. Next. So for plastics, we talked about that a little bit earlier too, but there are two kinds of plastic that most hobbyist formers work with, styrene and ABS. And since I know that we've got a lot of technically minded people here at Arisia, I put the full chemical names.
Thank you.
I don't think you'll ever hear anyone refer to acrylonitrile butadiene styrene in conversation, but ABS and HIPS are the two most popular ones. This is HIPS. And HIPS is easier to work with, but it's a little bit less durable. ABS and HIPS both share the butadiene, which is the part of the chemical composition which makes it elastic. ABS has a lot more of it, so ABS is very, very stretchy. When you try to put it down on a form, it actually fights you, and you have to really press to get it to stay, whereas styrene sort of naturally wants to take the shape that you're giving it, so it's much more forgiving. But styrene tends to crack on a tear, so if you get a little tiny chip in it, you just pull the sheet in half with your hand, even if it's 1/8 thick. So there's sort of a trade-off. You know, do you work with the cheaper, easier material, or the harder to work with, more expensive material? ABS also picks up moisture from the air, so if you're going to be forming it and you store it in a garage or something, you actually need a hot box to dry it in before you can form it, which is basically you put it in a 200-degree box for, you know, anywhere from a couple hours to a couple days until you measure the humidity inside and it comes to the right levels. So I personally find that it's easier to work with styrene, and if a piece breaks, I just make a new one. So, you know, that's my take on it. I've made 65 sets of clone armor, and I've done probably 4 or 5 replacement pieces out of the whole thing. Each set of armor has 17 pieces, so, you know, overall my averages are going pretty well right now. If you do start to get into this and you start looking into the plastics, you'll find some ABS is very cheap and some ABS is very expensive. A 24-inch square of HIPS costs me about $6. A 24-inch square of double smooth ABS costs about $15. But then there's another ABS that costs the same as the HIPS. That's called hair cell. And hair cell has a bumpy texture on the inside. And when you form, that translates through the outside. So you'll never get a smooth piece out of it unless it's a very shallow piece that's not stretching too much. If you're going for a bigger piece and you use hair cell, you'll end up with a bumpy texture on the outside that you then have to sand out and adds a bit more work. So something to be aware of. It's not as great a deal as it may first seem. No, because what happens is the texture, I guess if you were really patient, you could probably sand all of the texture off on the inside, but that would be a nightmare. Because as soon as you pull it, all that texture, I mean, a good system that with a strong pump is sensitive enough that I've actually seen fingerprints translate through to the finished form. So those little bumps really can kill you. So last part here is the plastic carrier frame. You know, as I mentioned, you know, this is pretty excessive. This is welded steel. I mean, this could hold a lot more than a, you know, hair-thin piece of styrene to pull a little tiny clone face. But I did this as a personal exercise just because I got a welder and it's fun and I wanted to play with it, and so here was an excuse. If you were doing something like this, you could very well use a wooden frame. I've seen people there, I forget what it's called, but there's something that's essentially an industrial grade erector set where you can buy all these different pieces and just sort of screw and clamp them together.
Dexion?
I think that's it.
No, stay away from Unistrut or 80/20. Stay away from Dexion.
But you know, people can play around with things like that. You know, I went with this because this is what I use on my big system, and for purposes of demonstration, it's nice to show it that way. All you really care about is that you want to keep the plastic in its shape when it comes down here, and you don't want it to slip out. And there are 2 ways I've seen people do that. A wooden frame with screws that you actually push through, so you're screwing the plastic into it. Because then when you stretch it, it's not going to pull out. These little spring clips from, you know, standard office supply store are surprisingly good at this because they're spring, they're maintaining constant pressure. As the plastic gets thinner as it stretches, the clamps just clamp down tighter on it. So if you put enough of them, it'll hold it pretty well. On my full-size table, I use the really big spring clamps, and I have 4 down each side. And it's able to hold, you know, the sheet against some really big pulls. Like some of my forms are about this tall off the table, and it will hold it nice and secure. Because as it stretches, the plastic gets thinner, it wants to pop out, but the springs just clamp down tighter. So it's a nice way to get some extra value out of things that you probably have sitting around your office. Not that I'm encouraging stealing office supplies, because I wouldn't do that. So as an example, on the left is the system that we used to use, which was a plastic frame. And actually, Garrett, who's out here in the audience, was here one night when we set one of those on fire. We were forming too long, and we were cycling through the plastic too quickly. We had 3 or 4 frames, and you'd put one in the oven, let it cook, pull it out, put the next one in the oven. We were cycling through so fast that it built up enough heat that we started, why is there smoke? Uh-oh. Pull the sheet out, toss it to the side, and let it burn itself out outdoors. On the right is my system while it was a work in progress, so you can still see the inner workings. And basically, your carrier is up here. This handle raises and lowers it. The heater gets mounted to this area. So you pop it into the upright position, the plastic is under the heater. When you're ready, you pull the lever down, and it brings it perfectly straight and smooth down onto the forming surface. So you never get an issue of misalignment. If you have a freehand thing like this, you put your plastic down like that, you hit the edges and you don't get a pull and you've wasted your plastic. So you really want to try to make sure you get it straight. If this was a bigger system, I would have guideposts, but since it's so small and I can basically go like that to guide it, there's really no reason to engineer something that would stick out and make it harder to transport. But it's just something to think about when you're building it is how often are you going to be doing it and what materials are appropriate based on that. There's no reason to spend $500 on steel and welding if you're going to be making small pieces to make model train pieces out of, for example. That's one thing that hobby vac forming is popular in is RC cars, RC helicopters, model trains, things like that. So those are people that are working with smaller pieces and don't necessarily have to deal with big contraptions like that. All right, so it's just a run through of what we're going to do. The next frame is actually a video of building this system, and sadly, because we don't have the speakers hooked up, you won't get the epic music. If you can tap the video.
Is this presentation online, by the way?
It will be. I didn't want to do spoilers. Yeah, it's
coming out of the iPad, so.
Yeah, the music, I used some of the soundtrack from the Clone Wars movie, so it's this big epic battle scene where they're marching into war, and it makes it all sound much more exciting than it really is. So, loading up the plastic, putting on the little clamps, and don't worry, I do accelerate things. You don't actually have to watch this in real time, because that would get old fast. But I've magically finished, raise it up to the top. Unfortunately, I'm not able to get good video of the heater component because it's really, really hot under there, and if I try to videotape it, it hurts. So I tried that once, and before the heating wires actually got to a nice red hot point where they look cool, it was uncomfortable and I didn't want to melt my camera.
We need to build a robot.
So this is the worst piece of my armor. This is the chest, which is the biggest component. And here you'll see the sort of slow motion. The plastic stretches a long way and then pulls down tight. So, as long as you have a good temperature and a good frame, you can get away with a very large piece like that. And then the trimming part is really fun. That's when we get to cut ourselves to ribbons with razors. And I really wish I could cut that fast because that would make my life a lot easier considering how many pieces there are in a set of clone armor. But basically you trim off all of the tight areas and then it will just kind of pop right off. As I say, now you do that 17 more times and you get one suit of clone trooper armor.
What's your website?
My presentation quit. Awesome. My website is stormtrooperguy.com. Let's get back in here.
3G battery goes down.
All right, and actually that was the last frame of the presentation, so I guess it's not bad that it chose to die where it did. So at this point, I'm going to actually do it, and you can see how it all works, just in a very small scale. That's okay. The last thing on there was the page where I said, here's my website, stormtrooperguy.com. So I think we've got that one covered. So basically just take the plastic, stick it in your frame, and put your little clips all around the edges. Just make sure they're evenly spaced so that your plastic doesn't fall out. And once we've done one little demonstration of this, if people want to come up and look at it more closely, play with it, we do have some spare plastic to experiment with. You can see on the oven here, I cut little grooves into the oven box. That's just to help me line up the plastic and make sure it's in the right space. I used a dimmer switch on the front control so that I could regulate the temperature of the oven if I wanted to. I don't really do that. I just turn it up to full because it's not a very hot oven and that doesn't hurt anything. And you'll notice also that I start poking and prodding this with my bare fingertips, even though it's 200-odd degree plastic. That's because I do a lot of this and my fingertips have almost no feeling remaining. But if you have normal hands, I recommend gloves because otherwise you'll be like me.
How do you bind the edges of your plastic? So you've now made vacuum formed pieces of your Stormtrooper. You adhere them to someone's chest. Now you have nice sharp edges where the plastic is cut.
Lots of careful sanding. You basically you trim it all out and then you spend a lot of time with sandpaper just getting nice smooth edges, and almost inevitably we find pinch points the first time you wear a suit. And usually because we're all very smart and plan well in advance, we do that on things like 5-mile-long parades through Boston in March. So by the end of the parade, we're all sort of bleeding and whining and saying, why do we do this?
And then do it again next year?
Yep, and then we do it again next year. Once you get the suit tuned, it's very comfortable, but the first couple wears are awkward.
Do you?
That's sorry.
How do you join the pieces of the armor?
That varies from person to person. My method is I use plastic cement from the plumbing aisle of Home Depot because it melts the surface and joins them. Some people use super glue. Some people use goop, which is an awesome adhesive. E6000 is another one. But it's really, for as many Stormtroopers as there are that many different methods of assembling the suit.
How do you hold it to a person's body? Do you build straps into the...
Straps, Velcro, a lot of us use magnets. Like for the shins of my clone armor, I have rows of edge polarized magnets down the back. So I put it on my leg and it just snaps closed behind. Because that's an awkward area to get to when you're in the armor, so having self-assembling suits is nice. Most people require assistance getting dressed too, so we actually did a presentation at the Higgins Armory Museum where we did dressing a medieval knight versus dressing a Republic clone trooper. And we compared and contrasted, and we basically use the same assembly methodology, just replace buckles and leather straps with elastic and Velcro, and it's the same general idea. So now the plastic is starting to get soft, and it's a little bit springy. The corners are usually the last piece to soften up, so to tell when you're ready to form, you really want to check the corners, and if those are soft, you're ready to go. Otherwise, the corner of the plastic will hit this and not go down any further. And now in the case of this oven, there's a cold spot in one corner just because of the way the heating element was built. So if I twist it around, it'll get in here. That's the hard, and everything else is nice and soft. But that little cold spot is still a bit too firm.
If you were to put a metal fan in there to blow the air around?
Even just putting a screen, like a metal mesh inside, would distribute the heat better. Alright, it's just about ready. My last corner is almost soft. And that's it. You have little, cute little clone flakes. Just toss that out. So we actually, this seems very silly and impractical, but we do a lot of events with kids. So one of the things we've been toying around with is, I decorated this one with Sharpies. So we were thinking if we were doing an event with little kids, we could do a presentation earlier in the day for the grown-ups where we make a bunch of little clone faces and then send those up to Fast Track. And kids could grab their little markers and color in their clone faces. So it's something we could do.
If you were making a whole head mask, how would you join the two halves together?
That's I'm doing another presentation like this at 3:30. We generally don't make the masks out of plastic. We do those out of rotocast resin, where that way you can get a 360-degree object with no seams. If you were to join two pieces of plastic like that, you'd probably have to do something where you cut little strips to make as a shim to join them, glue the strip to one side, butt the two up to each other, glue them together, and then finish the seams. But it's easier to do that out of resin.
Stormtrooper helmet, for instance.
The Stormtrooper helmet was engineered to be vacuum formed, so it's actually got convenient places where seams are hidden. The Stormtrooper helmet, the cap and the back is one piece and the face is another. And the ear caps were designed the way they are because they cover the seams. So it overlaps there, they don't join them at all. They just screw a piece over it and call it done. Because the Stormtrooper helmets were made with the express purpose of being very fast and very cheap to produce. And what's pretty exciting about the Blu-ray release of Star Wars coming out is everyone will get to see how terrible the costumes actually are. A lot of the Stormtroopers are held together with gaffer's tape. They're missing pieces. Their parts are on upside down. They've got cracks and breaks. You can see special effects troopers where they put pyrotechnics on them, and then they just left them that way. So in the next scene, like the trooper will just have a hole blown out of the chest of his armor, and they just left it.
Maybe that's
what
why
do
they
they
can
care?
never shoot straight.
Yeah, so that's what we do, and if anyone wants to come up and, play more closely, check stuff out, ask other questions, I wanted to try to make this as interactive as possible. The only thing I can say is don't put your hand in here, because it's hot, and it will hurt. So, otherwise, it's pretty safe to play with. Thank you. As I said, stormtrooperguy.com. I'll have all this stuff up online within the next couple of days. Yes, it's not like scorchingly hot, but it's hot enough that it would be unpleasant. If anyone would like to take home a little souvenir clone face,